Alright, perfect. We're going to go ahead and get started. Welcome. Thank you everyone for coming. This is a much larger crowd than we expected, so we're having to adjust a little bit, but I'm super excited to have you all here. My name is Steve Valhan. I'm the head of the math department at West Chicago Community High School. I have some esteemed colleagues here with me. I have Caitlin Beamish. She teaches sheltered Algebra 1 and Algebra 2. Katie Gorgas. She teaches sheltered Geometry and Honors Algebra 2. And then Aaron Hayes, who teaches co-taught Algebra 1, Honors Algebra 2, and AP Stats. And I mention what they teach because this philosophy is not for any particular group of students. This is for everybody. So I don't know if Aaron's done it a lot in AP Stats class, but co-taught, sheltered, regular, honors, we do it in all classes. So to give you a little bit of history, about this time last year, maybe a little bit earlier, I read the book Building Thinking Classrooms. I started trying some things in my Honors Algebra 1 class. Being the division head, I kind of brought this topic to my division. Some people started kind of playing around with some things, trying some lessons at the end of last year. And a lot of people dove into the book a little more heavily over the summer, and then really kind of started trying some things to start the year. So this is a little video that was created by some people from our building that kind of explains a little bit of our journey. And this was filmed probably, I would say, within the first month, if not earlier, of the school year. So we'll watch a short video and then we'll go from there.
My name is Caitlin Beamish, and I teach math here at West Chicago Community High School. This is my second year teaching. Over the summer, we read a book called Building Thinking Classrooms, which focuses on changing the way that we do math in the high school setting, making it very much more interactive and student-focused. So this year, as we started reshaping our curriculum, we really focused on ways to connect students' prior knowledge to what we're doing and the new topics that we learn. And we really have seen a difference in the way that students interact with the material, are really motivated in learning and extending upon what they know, and just re-engaging students in the math that we do.
So this is my 8th year here at West Chicago Community High School, and in my role it's always been my goal to kind of create more engaging experiences for the students in mathematics. And as we ran into the pandemic that year where everyone was teaching at home, that was really nearly impossible. And then when we came back, I really saw that need even more. Students were kind of disengaged and reluctant to kind of work with each other and talk with one another. So this Building Thinking Classrooms was a nice framework to utilize to try to kind of promote that to happen.
When I read Building Thinking Classrooms, I think it was just really eye-opening of just seeing a really hands-on way to get students more involved in the classroom. It gave just a really specific structure for a way to get every student involved. Putting them up at the whiteboards is kind of their structure to do it. So having students take the whiteboard markers, have them up at the whiteboards, talking with each other, doing the problems on the board. At first it sounded like something so small, I didn't really believe that it would make such a big difference, but then just kind of the more that I kept trying it, the more that the kids loved doing it. They were so engaged. They loved having the non-permanent space up there to make mistakes, to be able to erase, to fix it. They started talking with each other, started figuring out each other's mistakes. I didn't even have to help them with it. All of those things just really helped the students to take ownership of their own learning.
Really, when I kind of think about our kind of philosophy or goal of living, learning, and leading here at West Chicago, I think the Building Thinking Classrooms really helps with that learning and that leading part. Our goal as educators, regardless of the content that we have, is always to create thinkers and learners. To be a good learner, it's not sitting in a classroom listening to what a teacher says and then just regurgitating what they've said onto a piece of paper. We're trying to get them to think mathematically, to think critically, and really in all subjects that's what we want them to do. And in terms of that leadership piece, to be a true leader, I think you have the ability to work with a variety of different people, to come and try to solve problems together and complete tasks together, because when we get out into the professional world, people are going to be working with others and having to collaborate with one another.
Part of the Building Thinking Classrooms model is randomized groups. The whole point of randomizing it is that students get comfortable learning with whoever they're with. So they kind of, I think, are pointed back to the point of math, which is just learning how to problem solve and learning to do that with whomever. And I think when you randomize the groups, the students end up having to learn to explain things multiple ways because they're not just used to one person's learning style. They have to really be able to explain it in many different ways, which I think deepens their understanding.
Students have really liked doing the whiteboard work, and we usually do it about 2 to 3 times per week.
My name is Bibi Sabra Kabir, and this year I'm learning geometry. I really enjoy that I'm learning geometry with my teachers and the students. I really enjoy that part that I'm stand up and doing in the boards with the students. It's really good. Instead of desk, you going to the boards and writing a question and then answering the questions. So I really like talking with the students about geometry, and they raise my hand and answer the questions. I really like it because it's more open your mind when you know the geometry, like math.
All right, so if you haven't read the book, I highly encourage you to read the book. But one of the things that Peter talks about in the book, technology. That was better than what I did last time. So, he jokes that problem solving is what we do at the end of the unit when we have the time and the planets are aligned, and, he talks, people say problem solving, they think word problems, and that's not what we're thinking about, right? So what we would say is that the reality of it is that problem solving is what we do when we don't know what to do. So our goal is to try to provide an access point for students. So to give them kind of something that they can accomplish with a little bit of prior knowledge that they have, and then just kind of stack some tasks on there to where they can continue to draw from prior knowledge that they have, and then be able to hopefully work together and come up with solutions to solve the problems that we're asking them to solve. And again, I think probably my favorite quote here is this one. And really what I think it's trying to say is, it's not about creating the most entertaining task, coming up with, something that's going to make students go like, oh my God, I want to solve this so bad. But the goal is really to create a mindset with your classroom and create students that are willing to think about anything that you give them. So I'm not trying to tell you that I want you to create the most engaging task. I want you to work on creating engaged students that will tackle any task that you give them. And so I would say that you guys all have everything that you need already. So you have whatever curricular resources that you have at your disposal. It's about figuring out how to take those problems and really kind of dissect them in such a way that students can engage with it right away, and then hopefully begin to, through doing things, internalize the understanding that they have, to avoid, as I said in the video, just regurgitating what they watched you do on the paper. So we're going to walk you through a couple of different activities, kind of explain some of the things that we've done. So everyone has a card.
My name is Caitlin Beamish, and I teach Sheltered Algebra 1, which serves our ESL students. So as we go throughout an example, go back one more, I'm sorry. Yeah, right there. What I want you to think about as we go through not only Algebra 1 example, but any others, is something that we're finding is more so often we underplay what students can do and the knowledge that they can bring to the table in order to connect to the ideas that we're talking about. And like this quote says, that if you spoon feed them everything, they will gladly accept it from you. So the more that we can get them thinking and introducing topics and connecting ideas to what they already know is our goal. So here's how we're going to get started. You can go one more. Okay. Oh, too far. You didn't see that. Okay. At your station, you have a packet. Please try not to flip through the pages. Don't steal my thunder just yet. Okay? So you're going to start off with your group, and I have a task that I gave to my Algebra 1 students this semester. So here's how it's going to work. You have an emoji puzzle to solve. You, as a group, are going to solve the puzzle together. There's going to be 3 roles/writers. So my first role is going to be writing the work line by line on your poster with the marker. Okay, so I want to see numbers on your poster. My role number 2 is that the next person is going to write in words what strategy you use to solve the problem. And then my third role is that the last person is going to write in words, what do you think this lesson is on? No context, but just thinking about the process and math that you're doing, what is this lesson on? Okay? We're going to start our roles from tallest person to shortest person. And if you have a fourth person, don't worry, you'll be a writer eventually. Okay? You have 2 minutes, ready, set, and go.
That's how I mean, I am. Yeah. I was and I know I would have kids who would just
Put like, okay.
7, and then I would have the kids do the divide by.
We did kind of skip the lines of like.
Now, is this like?
We got to 10.
Is that what we're supposed to?
I don't
How
know.
we're supposed to be writing numbers
14
here?
plus.
Yeah.
Okay.
And then
No, we're both. 2 to 3 both words. Choosing words, what do we do? Using words.
I'm going to give you 30 more seconds. Again, your goal is to write in words what strategy you use to solve this problem. And then my last person write in words what you think this lesson is about. Or things like that. So what I want to do is I want to highlight one group that I have over here and what they wrote about what strategy they use, because I think they really hit it right on the head.
Can you hear me if I just talk really loud? Yeah. Okay. We started at the top and used the fact that all emojis were the same to find the value of the first emoji. Then we worked down each line to get each missing value. Our final step was to use the order of operations to find our final value.
Great, thank you. Yep. Now, if you have the ability to take a look at my slide that I have up here, but this is the version that I gave my kids. That's exactly what they wrote for me, maybe not as lengthy of a sentence, but they wrote that same idea for me. And what I gave to them is I gave them instead task number 4, which said that we're going to be talking about a solving strategy called substitution, and I had them write in words instead, what does it mean to substitute? Can you give me an example and how does it relate to this problem? So when I gave that question, I had students write a substitute teacher, or I played basketball and I had a sub come in for me. And that's exactly what we were going on. So as we go throughout these problems, you can see, Steve, can you go to the next one for me? This was actually the introduction to solving systems by substitution. I think a lot of you were like potentially equations or different things like that. This was our first day of solving by substitution. So if you take a look at the screen up here, and if you flip your packet to the next page, you'll see the same thing. The packet is what I give to my students. We would regroup as just we did together, talk about substitution, hear from different students, and bring their perspectives in together, and then they would all flip to the next page. By now, we've covered solving systems by graphing, and we've also talked about what it means to be a solution. So they have that prior knowledge. And now we're here. And we talk about, okay, well, we use substitution in order to figure out what the question mark had to be, which the correct answer was 114 if you got it. So then we bring them here, and we're like, okay, you're going to use your strategies that you used from before, and you're going to solve each of these for the appropriate variable. Just say go, and they just go ahead and do it. And it might seem a little like daunting, like that might seem like a big jump, but I promise you, don't underplay what they can do it, or they can get started. And especially when you have kids groups who are maybe stuck, I always refer back to the emoji. How did you know that the emoji was 5? Oh, well, I knew this one was 10, so this one had to be 5. And we're like, okay, we're gonna use that strategy in order to build it from there, okay? Can you go to the next one? So a lot of what we do in building thinking classrooms is the scaffolding. How do we continue to bridge up the difficulty as we go through? So just taking a look at the paper you're looking at, with your group I'm going to give you 30 seconds. This is where the fourth person, if you have a fourth person, is going to be the writer this time. If not, just go back to the first person. 30 seconds, I want you to write on your poster, what do you think the next step would be? What would be the next appropriate scaffold to be, or type of problem to give students? 30 seconds, ready, and go. Alright, let's regroup here back together. I have a group over here that I would like to share out for what they believe to be the next appropriate step here for these types of problems. We we thought that the next step would be adding variables, and then from there even building up to adding like, you know, little expressions. Go ahead and flip your packet to the next page. So that's exactly how I built it as well. As you can see in the top line, it adds to be just a number and a variable this time. They do some problems and then they would go into the last row, which has that number and then that constant over there. As we go throughout these, the way that I did this in my classroom is we all did the first page, we regrouped just like how we just did the second page, gave them some time. I like to put enough problems on there where my groups who are doing really well have enough challenge and problems to work on, while other groups who may be getting through one or two. We regroup, have a little bit of conversation, and then I go, here you go. We talked about substitution, you know what it means to substitute, so now the only thing I'm really ramping up is the algebra part to it, which there's going to be kids who need help, and they're going to need help regardless. So just continuing to brainstorm ways to continue to hone in that skill of substitution while scaffolding it up in the appropriate measures. This is another way, I don't believe it's in your packet, so if you can see the screen here, this is another way that you can scaffold that last task. Now, I'll be honest with you, I have not tried this yet because I gathered this from another presenter at a different math conference. So this is where we are striving towards as well. But we wanted to share it for you because we felt like it would be a good way to continue to bridge that challenge and ability flow. So as you can see the way that it works, you would start at 1A, do it as a group together, and then depending on how you feel about group A or problem A, you would go to either 1C, which is needing a challenge, or 1B, needing more practice. So again, just continuing to find ways to bridge that flow, whether it looks like this, whether it's just giving them some problems, but again, continuing to meet them where they're at for the kids who maybe have learned this before, can catch on really quickly, and maybe ones who need more help along the way. For some context, for solving systems by substitution, we spent about 2.5 class periods on it, and our class period's about 46 minutes. So I spent my entire first day doing this, giving them some time to just work through some problems and figure some stuff out. We formalized it the second day with some more notes and individual practice, and then the second half of the day was over there as a formalized like learning check. But that is an example of what you can do with Algebra 1.
All right, so now it's my turn. Can you hear without the microphone? Yeah. Okay, great. So for the geometry example, one of the things that's been a little tricky is you always hear, well, geometry is kind of like the exception to all the other types, right? So we've been trying to do some problem solving, right? This is like our first full year really trying this strategy. So a lot of what we've been doing this year is just troubleshooting. So I teach ESL geometry and honors algebra too, so it's been interesting seeing what crashes and burns in one class works really well in another, or vice versa. So we've tried a lot of things. But one of the most common issues that comes up with geometry is just you're dealing with so many images. You want kids to be able to start with a picture, label it, things like that. So we've been trying to come up with ways to handle this. So what you guys are getting now is one of the solutions that we've come up with. So this was a problem on dilations. They didn't know that yet. But what we did is we just took a piece of paper with all the images in it and we slid it in a sheet protector. So that way you have kind of a mini whiteboard on there, and when they're up at the boards, we just use like tape or magnets or things like that to put on the board. Because I don't want to waste 10 minutes of my class time just having a kid draw the triangle, label everything. If they can start with it, then we can get to the real math stuff right away. So what I want you guys to do is you're putting yourselves in your ESL geometry student shoes, and this is our second day on the similarity unit. So day one, what we did was we also had them up at the whiteboards, tying back to things that they already know. So like, okay, here's a stick man. Draw a giant that's 5 times as big as the original man. Or, okay, now here's a triangle. The sides are 10, 8, and 6. Draw a triangle that's half as big. So now they're 5, 4, and 3, or things like that. So using a lot of just that verbiage that they already know just from living life, right? And then at the end of the class period, we kind of formalized it and said, okay, what you just did right there, that's scale factor. So that's basically all the prior knowledge that you have. We haven't done anything with coordinate planes yet or anything like that. So your job is just, you're coming in, beginning of the class, day 2, see what you can figure out. So follow the instructions on your sheet. There are points where you will need to flag us down. Do so if you need to, but you've got 2 minutes. See how far you can get.
Should have a fine, like a small expo marker, so go ahead and use that expo marker, not the 3-hole marker on all.
All right, so let's go ahead and bring it back up front. Okay, so some of the things that you might have noticed. So one is just, this is a really handy way to make kind of a mini vertical non-permanent space, even if you don't have whiteboards around your room. So it's a nice option for that. The other thing is we try to section off this activity so that they can do a little bit, right, get through those first 2 problems on their own, but then they have that built-in stop sign. One, so that if they do something wrong at the beginning, they're not just continuing to do things wrong the whole way through, right? But then also it gives kids just kind of an end in sight, right? They're much more willing to try multiple problems if they know that, okay, I do these 3 and then I get to stop and check, right? And it kind of eliminates them asking so many questions along the way if they know that there is that built-in teacher touch point with them. The other thing is even just looking around at your boards right now, one of the things is like, not everybody did the second question right? So a lot of times I'll see something like this. A lot of people dilated it from point A again, right? Because you did A from the first one, so why not do A again? Now, in this model, right, I don't just tell you that's wrong, here's how to fix it, right? I'll say, okay, read number 2 again, see if you can figure out what you need to fix. If you can't, look around the room, see what other groups are doing, and see if you can get a hint of how you could fix yours to look more like theirs. Things like that. Now, some of you did some like formal geometry things like putting A prime, B prime, C prime, right? They don't know yet that, and they don't need to, right? The point is not to have it formalized yet, but it's going from things that they know. They're not going to say the word slope. Oh, I cut the slope in half or things like that. You guys know that, but it's drawing from all these things that they know how to do, even if they can't totally put the words to it yet. All right, we are going to go ahead and leave everything there. You can head back to your seats. We have one more geometry. Leave it. All right, so the other challenge as you're heading back to your seats that we hear about with geometry a lot and that our course team is trying to think through is just a lot of the topics feel very disjointed, right? You're jumping from trigonometry to quadrilaterals to graphing, like it's just all over the place in terms of what you're covering. So something like Algebra 1 builds on itself very clearly, very linearly throughout the year. So one of the things that we've just been brainstorming as a team is just, okay, what is a prior thing that they do know that we can connect it back to? So this is an example from our trigonometry unit. So if you want, there's 2 Desmos activities up there. You can use your QR code just to kind of see what this would look like. But we're coming from a school where we had transferred a lot of our curriculum onto Desmos before. Now that we're using this building thinking classrooms model, it's a lot more like pencil and paper, going back to the basics again. But we felt like we had a lot of really good stuff that we wanted to figure out how to use still. And there's tons of ways that we've been able to do that. So this is kind of a cool one. So we started, this is day 3 of our trigonometry unit. We started with connecting it back to what they knew about scale factor and similarity. So we had just done like 30, 60, 90 triangles, 45, 45, 90, and talking about those as like families of similar triangles, right? Well, now with trigonometry, we have the tools that we need to come up with a family of any angle, right? So like in this one, we're working now with the 21-degree family, right? So what we had is all of these like slider type tools. So we would make a 21-degree angle. This is now what we call like their parent one, right? Every triangle that has a 21-degree angle, right triangle, is going to come from that one. It's just multiplied by some sort of scale factor, right? So on the first day, all we did was use sine, really. We used only opposite and hypotenuse. It's nice because the hypotenuse is always 1. They have the opposite with them, right? So for this warm-up then, on day 3, they're told, okay, use this is your slider, right? Make the 34-degree family to find y for the opposite one. And it even has kind of a nice hint to help them know how to set up a ratio for it right above the triangle. Then from there, though, we would say, wait a second, we're a little stuck, right? How do we find x? Nothing's labeled on that one, right? Well, they know how to use Pythagorean theorem, right? So then they solved it with Pythagorean theorem after that. But then we had the conversation, oh, okay, that was really annoying. There were so many decimals. That took forever. There has to be a better way, right? Why can we only have those like sliders with 2 of these sides? And at that point, they know opposite and hypotenuse. So what we did then is we sent them back up to the whiteboards. And we gave them, so this other Desmos activity that literally just has the 3 sliders on here. So we said, okay, this is going to generate your parent for the sine ratio, cosine, and tangent. Again, they don't know that, but here's the opposite hypotenuse, here's adjacent hypotenuse. So now their job is just to decide which of these is going to help them create the family that they need to. So then when they're doing this work up on their whiteboards, they're in groups of 3 typically, so one person's role was to bring the Chromebook up and their job was to make the parent for all of these. But then the other students, one of their jobs was to draw these 2 next to each other, right? So here's the parent that we made for number 2. This was generated just from that slider, right? And then here's what we're trying to get to. And then the other student's job was to figure out the scale factor, right? And for these ones that have the 1, pretty straightforward. With other ones, they have to go back to some stuff that they know about similarity and how to make scale factor. So just some interesting ways to, one, just like incorporate some of that cool technology stuff can definitely still be used up here. But then also just realizing there's a lot more connections back to stuff that they already know in geometry than sometimes we give them credit for. All right, so now I'll pass it over to Aaron for an Algebra 2 exam.
Now, some of the things that Mike touched on this morning, was the fact that you have a lot of the material that we already know. And that's one of the things that Steve had come to us and talked through. And I had come up with maybe about 10, 12 years ago, this idea, if you remember the analogy of I call them turning up temperature problems. It's like you put the frog in the boiling water, it jumps out, but if you put a frog in room temperature water and turn on the heat, it won't notice the temperature going up. Not that I'm advocating hurting frogs, but it's one of those things where I found early on that if you take a step back from even some of the early examples that you would normally be giving students in class, you could have them do a lot of the work for you. So this was what we originally came up with when we used in our honors classes, and I know of it was also something similar was taken down to our regular algebra classes, where I gave them just some simple examples of solving radical equations, but it's just like square root of 9. Square root of x is equal to 9. So, oh yeah, I can do that. I just square both sides. And so after they do the first 2 questions, and they do this in groups at their tables, they'd come up, I'd check it, I'd give them the next problem, they would go back, and just go back and forth like that. That really worked really easy when Katie and I were talking about what to do in an honors geometry or honors algebra 2 class this year with it, because then what we ended up doing is, it looks like this. So I start up with this, I give them a couple of problems, they're up at the right boards, they do it, and this slide takes maybe 30 to 60 seconds. And I can just stand. Katie and I, if you watch us with our honors classes in particular, sometimes we're just sitting on a table in the middle of the room and we can just talk to the kids and say, yeah, you're right, great. Or, hey, group 5, take a look at group 7 and see if you can kind of get a sense from that. Because these are very accessible. I could give these to my algebra kids and I would be fairly confident that they could probably pull it off. So then we pull into the next one and then make it, okay, well, what happens if we have 2 roots? And again, very accessible. But we start to slowly build, and this is all, again, all stuff that we had before. You can even just see the background that I use in my smartboard slides there. But you can easily start to do this. Now this starts to get a little bit harder because, of course, what does the right side always turn into? X squared plus 9, and then you get to have that conversation for the 10th time. But it's probably that 10th time that period. But it's one of those things where, again, that you can help reinforce a number of things there. But again, it's all accessible things that the students already know how to do that you don't have to be the person going through and telling you. And so eventually it starts to, get cranked up. Oh, we have to move things. That one they love because it's a lot simpler than they think. And then you can double check in terms of, checking answers, and both answers work. And those are all almost toss away questions that you can toss at the kids. It's like, well, did you check both your answers? Well, why would I want to do that? I don't know. Why don't you check to see if there's a reason for it? But again, it's something that we already had. A lot of these are standard examples I would have done 25 years ago in my Algebra 2 class. I would have been up there chatting away and just, boring everybody to death. Where here, they're more engaged and they're working on things. And again, we can go anywhere from, sometimes I do it for 10 minutes. Sometimes it's almost a whole class period. I try to keep it down because the one thing that we're also trying to do is the question we get is, how do the kids take away from what they're writing on the board? Okay, and that's the thing that I, having done this for a couple of years, I kind of initially struggled with until the book came out. And then we had, for a number of years, these learning cards. They were, I forget the name of the guy who originated them in AP Stats. I made a set for Algebra 1, we started making them for Algebra 2, and Katie came across the idea of like, well, why don't we just give this to the end at the end of the lesson, because the way things are set up, and I can, if you want to see the whole presentation on this, I can send you that later. But you know, strategies, things to remember, a couple of examples. Sometimes we walk through them with it, particularly more in an algebra class. I would be a lot more structured in going through the examples. With our honors classes, oftentimes we're like, hey, you guys have done this, do it, and then double check it with your neighbor. And again, that gives them something concrete to be writing out, which again, gets a whole bunch of, you know, good brain activity there. But it will also then something that they have, they can take home and they can double check it. Because I know, at least with my algebra classes, the kids remember a lot more that they're up on the boards. And let's face it, my algebra kids rarely ever check their notes anyway. So I'd much rather have them more engaged in class and remember things from that, much as like what Kate was saying, than necessarily copying a whole bunch of stuff down. I think you're back up, Steve.
So, this is pretty new for us. So it's been a learning experience. There's a lot of challenges that we've come across. You know, you're going to run into days that go really well, days that don't. You're going to have kids that want to sit on the table and not stand up. A lot of different things that you have that can challenge. So just kind of some of the solutions of things. One thing I want to show real quick here is sometimes in terms of the note taking, which is I did a more of a introductory presentation on this, and that was one of the most popular questions. Like, what do you guys do about notes, right? And so sometimes my answer is we just give them filled out notes. So this would be an example from Algebra 1 to where these were actually the problems that they had just done at the board. And then we just give them notes and say, hey, these are just written down what you guys did, so if you need to go back and refer to them. And then we don't necessarily spend a great amount of time doing notes. It's more about them doing problems and practicing and talking with each other and asking questions, making mistakes, correcting mistakes, and things of that nature. So we've kind of played around a little bit, so sometimes that we'll do notes even with them, sometimes we'll ask them to, and I think, no, I'm not sure. Yeah, even here. So even in these, we ask them, write down one key takeaway. So can you put something in your own words about what you took away from that lesson for the day? So we've kind of handled those in a couple of different ways, but we do kind of try to at least get them to kind of internalize their thinking. I think you run into challenges of them kind of following procedures that you have, right? And so we're far into it now this year. You know, we're 3/4 of the way through the school year, and we still continually remind them of the expectations that we have of them at the board. So this is something from Kate where she will have then a little slide on the smart board and talk about the things that we want you to do. Work together, try hard, trade the marker, and have the continual reminders about that, okay? I have a QR code in the beginning. I see some people taking pictures. You can take a snap of the QR code and you'll have the whole presentation as well, just so you know. So just that continual reminder, it's needed. They constantly need to be reminded. I think another one of the kind of challenges that we've had is that student stamina, right? In the beginning, they're not really used to them doing so much math all on their own for 46 minutes, even 40 minutes. So all of a sudden, you get the students that, you know, they stop being a good group of 3 and I'm all of a sudden over here with my friends and I want to kind of talk there. I will just say again, continually reminding them, and I feel like it has gotten better over time, right? They just get used to that being the expectation that they have in the class. So the more often that you do it, I think the better. I think in the beginning of the video, you know, Kate was saying we do it 2 or 3 times a week. I think it's probably closer to 3 times a week at this point. We look for any of those lessons where I can say, hey, they've got a little bit of prior knowledge about things, or I can give them a little bit of information, and then they should be able to roll with it. And so we are continually looking to kind of try to find that. So here's an example, so quadratic formula for Algebra 2. we kind of talked to them about, hey, here's the standard form and here's what A, B, and C was. So that's a little bit of information I gave. Now you guys are going to go up to the board and here's the problem. So first step, let's identify A, B, and C. Second step, I'm going to give you the quadratic formula. All I want you to do is plug those numbers into the quadratic formula. And we have stopping points. So again, we talked about that. I think we utilize those stopping points also to kind of help balance the feedback that we get. Like, I'll be honest, I'll have people come in and be like, oh my God, I did building thinking classrooms, all 5 of my classes, like I'm exhausted today. I feel like all I did is like run around from one side of the room to the other side of the room. So you're gonna have groups that work faster than other groups. So I encourage people to say, let's have enough problems and then let's have a time frame in mind. Like, I wanna spend 4 minutes on this part. Do I expect everyone to do all 4 parts? No. But hopefully then, within that time, the faster group, they've done all 4, I can give them a little feedback, yeah, you're good, go on to the next part. I can work and kind of give some information to other people, like, oh, no, hey, this one is, you know, remember, the sign to the left always goes with that number, that needs to be a -9, and things of that nature, and kind of give some feedback there. So that was kind of something I think that we've developed once we kind of struggled with, hey, they've got a bunch of problems, and then all of a sudden a bunch of people are in different spots. So we kind of broke those up and just kind of continued. And I give a ton of credit to everybody in my department for just identifying problems and not going, this is terrible, this isn't going to work. But they've said, hey, we're struggling with this, let's find a solution. So we've kind of just tried to develop some solutions along the way. And you know, we're continually kind of trying to grow in this process. This is the wrong link, which I will fix. But I think that's the other thing that people will talk about is like, how do I know that when everyone goes back on their own, that they can do it, right? So if I work in a group of 3, like what's the difference between my group knowledge versus my individual knowledge? So we have tried to be intentional of having time for students to go back individually, practice some problems. We went to the ITTM Math Conference, I think that's where it got brought up. I don't know if you've heard the idea of the mild, medium, and spicy problems. So we kind of have different level problems there. And so I may say, okay, hey, everyone, you know, we're going to go back to your seat. Here's some practice here. I want everyone to do 4 problems, and you have to try at least 1 medium. You want to do the other rest mild, fine. If you think that you've really got it and want to challenge and do some spicy, great. But 4 problems, that's the expectation. 1 of them has to be medium. And so then just being able to kind of give some individual feedback or just kind of assess kind of the individual learning that's going on. So those are kind of some of the challenges that we've come across and ways that we have tried to solve them. This is actually from the other presentation I got. So these are actually from, I did the presentation with Scott Miller from the Central. This is quotes from his students about utilizing random groups and vertical spaces. Does everybody love it? No. But I do feel like the vast majority of our students like enjoy that format. One of the greatest things for me is whenever I hear kids go, like, oh, this period's over already? And I get that in this format. They're thinking, they're not just sitting there copying down what you're telling them. So the last thing, here's just some resources that we have. And again, I'll flip back to the first slide. You can scan the QR code, which has the presentation here. A couple of random group generators. So outside of using the card format, some of them you can create a Word doc of all the students in your class. You just copy it. You can even like quickly eliminate the kids that are absent, hit the how many people you want in a group, hit randomize, and it just kind of kicks it out there and puts kids in groups. In the beginning of the year, we started with non-curricular tasks with kids up at the board. So again, if you haven't read the book, that's one of the things that they talk about. So you're utilizing those non-curricular tasks to kind of teach them what it is to be working in a building thinking classroom. So there's a building thinking classroom Facebook group. That's just a link to a bunch of the non-curricular tasks as well as the curricular tasks here. And then we also have a link here, and again, I'll share everything with you guys here, that I just went through and found some different lessons that we have. So I have a link. They're all PDFs because it's Google and it's the easiest way to give access to. So I apologize for the inability to kind of edit it, but there's Algebra 2, Algebra 1, and Geometry lessons, about 12 for each. So I tried to kind of make some notes onto the side to help you out. But again, there's contact information on the very first slide. If you're clicking through anything and you're like, I'm not sure exactly what you guys are trying to get at here, feel free to reach out to us. We're happy to help you out however we can. So I don't know what time this is supposed to end.
Right about now.
All right, perfect. So if you guys have any questions, feel free to stay back and ask. I think that's so much for coming. Have a good rest of the day.